Hi everyone, my name is Rob from RobOps, and today we're talking about AWS Cloud WAN, AWS's managed global networking service for connecting VPCs across regions through one central policy. AWS Cloud WAN is a managed global network service from AWS. At a high level, it gives you a central way to connect VPCs across regions and extend that connectivity to other network entry points like client VPNs, direct connects, and even transit gateway. So instead of thinking of your network one region at a time, Cloud WAN lets you think about it as one global network that's controlled through a central policy. That policy becomes the foundation for how connectivity is built and managed across your environment. So why would you use Cloud WAN in the first place? The biggest benefit is centralized control. Instead of managing networking region by region, Cloud WAN gives you a single global network model driven by policy. The second big advantage is segmentation. You can separate environments like production, development, and shared services while still controlling exactly how these segments communicate. And finally, Cloud WAN gives you a cleaner way to scale connectivity as your environment grows, especially when you're dealing with multiple AWS regions, remote users, or hybrid connectivity back to on-prem. Now that we understand what Cloud WAN is and why we'd use it, let's put it into practice. For this experiment, we're going to recreate this architecture by developing a VPC in US East 1 and another VPC in US West 2, then connecting both of them into a single AWS Cloud WAN core network. We'll use Terraform to stand up the VPCs and the EC2 instances running in them, and then in the console, we'll walk through the Cloud WAN setup, piece by piece, so you can clearly see how the network will come together. The goal is simple. Build a cross-region network where both VPCs are attached into Cloud WAN, and then verify that connectivity is flowing through that centralized network. All right, so jumping back into the code view, we're back in the AWS Networking Resources Demos repo, and if we open up the modules directory, we're going to notice we have a Cloud WAN module that we recently added, and this is going to be the module that's going to bootstrap the Cloud WAN configuration. And if we go to examples, we'll notice that we have a Cloud WAN demo, and we have a main and outputs and a variables.tf, along with the README. So if we open up this README, effectively our demo today is going to stand up a VPC in US East 1 and a VPC in US West 2. And we're going to put EC2 instances in each of these VPCs. These EC2 instances are going to be running a simple script that's going to emit on port 8080. And what we're going to try to do is first stand up those resources and attempt to reach the other EC2 instance in the other region with no connectivity, and it will obviously fail. And then what we're going to do is we're going to deploy our Cloud WAN, and we're going to actually see how we can link these two VPCs cross-region using AWS Cloud WAN. So our first step there in the README is effectively just going to be doing some targeted Terraform applies. What this is going to do is create two VPCs and two EC2 instances running in the public subnets of those VPCs. And so if I just go Terraform init to initialize my backend, and then I run the simple targeted applies, this is going to apply my Terraform. And as you can see, we have about 24 things to add, so I'm going to click yes and kick off the apply. Alrighty, so our apply has completed, and we've added 24 different resources, and we can see the private IPs of our instances along with their public IPs as the outputs. And so what we're going to do now is just verify that these resources have been deployed. If I switch back to the console, I'm going to see I have a new VPC in US East 1, and if I go to US West 2, I'm going to see I have a VPC B. In the same way, if I go to EC2 and I go to instances running, I'll notice I have a T3 micro running in US West 2, and I have a T3 micro running in US East 1. And so what I'm also going to try to do here is simply connect to the instance. And so do that, I'm just going to click connect, and then I'm going to connect via the EC2 console. And this is just going to SSH into my EC2 instance. And what I'm going to try to do here is just curl my local IP on port 8080 to verify that the script that I'm running is running. As you can see, I get hello from US East 1, host IP 10.50, 10.1.229, private IP 10.5. So the script is running as I might expect it on my host. But now if I try to ping the host on the US West 2 instance, and by doing that, I would effectively just need to curl the private IP of app B, which I happen to have handy here. So if I just curl HTTP, the private IP on port 8080, nothing will happen. And nothing will happen because we have no connectivity established. And so this is almost expected. But what we'll do next is set up our core network and revisit this experiment and watch the connectivity flow. So to do that, what I'm going to do is go back to my EC2 console, and I'm just going to go and type Cloud WAN, and this should take me to the network manager page. And so if I go to global networks, I can see I don't have anything. And so what I'm going to do is click create global network, and I'm just going to call my global network, and it'll say RobOps global network. And there's advanced settings here, but we're not going to add anything. We're just click next. And here it's going to ask us to create our core network. And so we're going to keep this clicked, add core network into your global network. And we're just going to call it my core network. And it'll say RobOps' core network. So here in the network policy settings, they're going to ask for an autonomous system number. And this is just a range that we would use to define our new core network. So because we're just using VPC attachments, we don't need to think too deeply about this. It matters more once you add BGP-based integrations like Direct Connect, VPNs, or Connect peers. And so for that reason, we're just going to use the example range here. When they say edge locations, we're going to have US East 1, and we're going to have US West 2. And so if I find that here, those are going to be our edge locations. Segment name is just going to be development and testing. And then I'll click next. And this is going to set up our core network. So I'm going to click create global network, and this is going to kick off the process to create our network. So now that our core network is up, we're going to click into it, and we're going to see effectively our network. And we have our edges in US East 1 and US East 2. And if we go into our core network, we're going to notice the configurations that we've set up. And specifically, if I go into policy versions, we're going to see our policy. And if I click into this, I'll notice we have a few different details here. And I'm going to click edit. And when I edit my policy, I'm going to have visual editor checked. And I'm going to go to attachment policies. And I'm going to click create attachment policy. And the rule number, I'm just going to set it to 100. It's just an arbitrary number. And associate type, I'm going to say segment name. And our segment is going to be development. That's the one we set up when we created our core network. And we're going to leave the attachment acceptance option to inherit. And in the condition logic, we're going to select tag value equals, our key is going to be segment, and our tag value is going to be development. And we're going to create this attachment policy. And now we're going to click create. So as you can see, we have a new policy version that was generated called latest, and it's going to generate and go into production with our network shortly. So now that our new policy is ready to execute, we're going to click highlight it, and we're going to click view or apply change set. And you can see what was modified here, our core network config, segments, and attachments, and I'm going to click apply change set. Then it will switch to executing. And once that's executed, it should come into play. But in the meantime, what we're going to do is create our first VPC attachment. And so to do this, we're going to go into our global network, core network view. And we are going to click create attachments. So we'll go to attachment, click create attachment. And here we're going to just simply call it my attachment VPC A. type is going to be VPC. Region is going to be US East 1. And we're going to do one subnet per AZ. And that's going to be this VPC. And we're going to do the public subnet. And we are going to add a tag called segment development. And then we're going to click create attachment. You can see it's pending acceptance. And so we're going to actually just create our other attachment here for VPCB. This is going to be in US West 2. And we're going to click VPCB. And we're going to do the public subnet as well. And here we are going to do the same thing. So segment development and create attachment. And so these are going to create the attachments that we're going to then associate to our segment. So now that we've created both attachments, we see that it's pending attachment acceptance. And so we're going to highlight this. We're going to click accept. And this is going to say accept attachment segment development, and we're going to click. All right, so now our attachments are available. And now what we need to do is just update our route tables. And so for that, we're going to go back to our VPCs and we're going to route tables. And we're going to the public route table of VPC A. And we're going to go routes and we're going to click edit routes. And what we want to do is create a route on 10.60.0.0/16 to our core network for traffic going to US West 2. And so here I'm going to click create, and that's going to create the route. And then on the other side of this, I'm going to go into US West 2. And here I'm going to go public route tables, routes, edit routes, and I'm going to do the same thing, but instead of 10.60, I'm going to do 10.50.0.0/16 and core network AWS network manager and click save changes. And so now that our routes are updated, we're going to go back to EC2 and we are going to connect to our instance. And we're going to attempt to traverse the network. And so the first thing I'm going to do is just curl locally port 8080 to prove that our script is running as we might expect it, which it is. And now I'm going to curl our instance, or I guess the private IP of our instance running in US West 2. And so I'm just going to copy the private IP on port 8080, click enter. And as you can see, hello from US West 2. Hostname 10.60.60 internal IP. So as you can see, our Cloud WAN has now effectively connected our two regions, and we've established connectivity through the creation of a segment and VPC attachments that we associate to that segment. Cloud WAN is powerful, but there are a few limitations and trade-offs to keep in mind. First, it's not always the right answer for smaller or simpler environments. AWS positions Transit Gateway as a strong fit when you operate in only a few regions and want to manage peering and routing yourself, whereas Cloud WAN is aimed for a more policy-driven global network. Second, Cloud WAN pushes you towards a policy model, which is great if designed well, but it also means you need to think carefully about segments, attachments, and how traffic should flow. By default, segments are separate routing domains, so the design work matters up front. And third, Cloud WAN does have some service limits and integration constraints. That doesn't make it a bad option, it just means you want to understand the boundaries of these services before making it a foundation of your network. AWS offers a variety of alternatives across various networking products. From very simple setups, you can use VPC peering. For more complicated projects, you can use Transit Gateway. And if you have global networking requirements and a vast network, AWS Cloud WAN is a good option for you. Depending on your use case, I've listed the advantages and considerations you should be making before you make any architectural decisions. And as always, if you enjoyed the content of today's video, please consider liking and subscribing. It really helps out my channel. And if you are interested in similar content, please feel free to comment down below any questions or recommended videos that you'd like to see me make next. And as always, I appreciate you. Thanks for watching and have a great week.